Hi, I'm Miss Hearn. If you find this video helpful, please give it a thumbs up. That helps other students to find the video. You can also subscribe to my channel, Miss Hearn Mathematics, for more math videos. We're going to start with the idea of how to find the distance between any two random points on a graph. So, for example, let's say I have a point in the xy coordinate system, one here and one here, and I want to find the distance between the 2 points. Okay, so the length of the line segment that would join the 2 points, in other words. One way we can do this is, since the xy coordinate system is set up as a grid, we can imagine dropping a line down from the top point and a line across horizontally, forming a right angle. We have a right triangle, and pretty much everybody is able to remember the Pythagorean Theorem, I guess because we start so young with it. If you call this side A, this side B, and this side C, remember that A squared plus B squared equals C squared. If you know the coordinates of these 2 points, let's say this is x2, y2, and this is x1, y1. Those are not powers, those are subscripts. These are just a way of saying point 1 and point 2. If you know the coordinates of the points, you can find these distances A and B, and then you can use the Pythagorean theorem to find C. For example, here, A is going to be the vertical distance between y2 and y1, which you can get by just subtracting the bigger y value minus the smaller one, or the smaller minus the bigger and just using the positive version, the absolute value. And then for B, it's the horizontal distance between these two x values, so it's x2 minus x1. And then C is the distance, which I'm going to call D, which we're looking for between the 2 points. Instead of, I'm going to move this C squared over here, by the way. Instead of C squared equals A squared plus B squared, we can think of this as D squared equals, instead of A, we have y2 minus y1 being squared, plus, instead of B, we have x2 minus x1 being squared. Or in other words, and I prefer to put the x's before the y's, so I'm going to just use the commutative property of addition to rearrange this a little bit. In other words, d squared is x2 minus x1 squared plus y2 minus y1 squared. We don't want the distance squared, we want the actual distance. So we could use the square root property to see that the distance, and I'm going to move this down a little bit. I don't really need to remember the plus or minus in this case. So what we have here is called the distance formula. It's the distance between 2 points, x1, y1, and x2, y2. All you need to do, I'm not going to expect you to develop the formula like we just did, but I do need you to be able to remember the formula and apply it. For example, I might ask you to find the distance between the point 4, -1, and -6, 3, express in simplified radical form. So what that means is that the answer might not turn out to be an integer. It might have a square root in it, and you want to simplify as much as possible, and then also round off to 2 decimal places. Your exact answer is the radical. And when you round to 2 decimal places, this is really an approximation, because there are a lot of numbers you can't represent as a terminating decimal. What we want to do is plug into our distance formula. We just have to decide which point we're going to let be our x1, y1, and which will be our x2, y2. It doesn't matter. It'll turn out the same either way. So let's say this is x1, y1, and this will be our x2, y2. Okay, so plugging into the formula then, we have the distance is equal to the square root, and then we have x2 minus x1, so that's going to be -6 minus 4 squared plus y2 minus y1, so 3 minus -1. And I purposely picked 2 points that have negative coordinates because I want you to make sure and pay attention that you don't make sign errors. So we have distance equals -6 minus 4 is -10. So we have -10 squared plus 3 minus -1 is 3 plus 1, or 4 squared. So the distance is going to be equal to the square root of, and then we have 100 plus 16. So the distance is the square root of 116. Okay, now 116, so this is the distance. Okay, okay, but it's just not in a format that we necessarily like. We need to get it in simplified radical form. If this number is not a perfect square, we want to see if any of its factors are a perfect square. The way that I prefer to do it is to look at the prime factorization. You might just divide out perfect squares, which is fine also. But I like to start with the lowest prime number 2 and divide in as many times as I can. So for example, 2 goes into 116 58 times, 2 goes into 58 29 times, and then 29 is a prime. So we're going to say that this is the square root of 2 squared, we have 2 factors of 2, times 29. Now the square root of 2 squared is just 2, so we have 2 square roots 29. So how's everybody doing so far? Remember, if you have any questions, you can always type them into the chat bar. So this is the exact solution, 2 square roots of 29, and we also want an approximation. So I'm going to open up my calculator here. So I'm going to take the square root of 29 and I'm going to multiply that by 2, or you can just take the square root of 116, doesn't matter. And we're going to get 10.77. Now if you think about it, 10 squared would be 100. It makes sense the square root of 116 would be bigger than 10, square root of 100. And 11 squared is 121, so it makes sense that the square root of 116 would be a little less than 11. So it's reasonable that our approximation would be, we have that this is approximately 10.77. So we just found the distance between 4, -1 and -6, 3 in 2 different ways. The exact distance, 2 times the square root of 29, and the approximate distance, 10.77. I hope you found this video helpful. If you did, please give it a thumbs up. That will help other students to find the video. You can also subscribe to my channel, Miss Hearn Mathematics, for more math videos.